Okay. Good afternoon. My name is Deepesh Yadav, and the title for my project is AI for Sustainable Agriculture, which is predicting the optimal crops with the Altair Rapid Miner and AI Studio. This contest, the data science context, is organized by National Institute of Technology, Tiruchirappalli, and powered by Altair Rapid Miner platform. So the theme and the problem statement for my project is the theme is agriculture. I took this theme because I saw the data says the 40% of Indian farmers face the losses due to the poor crop choices. And this problem happened because of there is no data driven guidance given to the farmers for the crop selection, which ultimately lead to the low yield, and also the overuse of fertilizers, which is the which lead to the soil nutrient depletion in the soil, and the climate unpredictability lead to the worsening in the crop failures. Now the objective of this project is to build an AI model which can recommend the crops based on the soil and the weather data. Okay, so if I talk about the AI studio, why I use this studio, because this AI studio giving the multiple features which can be used to create a complex workflows without even any coding. Just you have to drag and drop the operators given in the AI studio. It is like end-to-end data science platform which is integrating the different data pre-processing techniques, doing the data modeling and the validation and the deployment in only single tool. There is also feature of auto ML and the explainable AI, that is we call it XAI. The auto model computes algorithms like XGBoost neural networks automatically, and also it gives the feature like SHAP value. We can calculate the SHAP values, which ensures the transparent and trustworthy predictions by the model. Now, if I talk about the scalability and the enterprise readiness, this AI Studio handles a large data set. It can handle large data set. It can integrate with the cloud services, databases, and the APIs for the real world applications. Now, if I talk about the data set, what data set I've chosen for to solve my problem statement. So the data set name is like crop recommendation, which I have taken from the Kaggle. The features in the data set are soil nutrients, NPK, the nitrogen, phosphorus, and the potassium, temperature, and the humidity, pH value, and the rainfall. The target variable we can say is a crop type. So basically there are 22 crop types given in the data set. Categories like there is rice, maize, ground, etc. And the total data set records are 2200 records with 8 features. Okay, so data powering the solution. So how we massage the data is like we do pre-processing. In pre-processing we do remove the outliers, we impute the meshing values. So in my data set there was meshing values, so I imputed by using the mean. You can use minimum, maximum, median as per your requirement. Now the attribute is generation. This is like comes under the feature engineering. Here we generate a new attribute as per our requirement. So I've generated NPK ratio. You can see here. So the NPK ratio is the ratio the nitrogen plus phosphorus by dividing the value of potassium. Okay, so then I did the normalization. As you see, the normalization we do because their values in the columns can be differ. Okay, so after doing the normalization, I got these features, 9 features. You can see the statistic here, and you can see the missing values are 0 and the type is like real data, and this the values like average, what is the mean and the max in the dataset columns. Okay, So to okay, now the next step is modeling workflow in RapidMiner. How we model the model, how we can create a workflow. So there are two type of methods. The first method is custom process. In this we create the flow by using different operators, and we do some pre-processing, we do some training validation. You can see here first step is data pre-processing by reading the CSV file, like importing the data by using the read CSV operator, then inputting the missing values by using replace missing values operator, then generate the attribute, create a new attribute or columns by using this operator generate attribute. Now we are doing the normalization. So these are the things that I have done in my data set to make it fit for model training and validation. The next step is model training and validation. So I have used k cross validation, and here I have taken k value as 10, which is by default, and the sampling type is stratified. If I talk about the model I have taken, this is the decision tree model I have chosen to go with the to predict the crops type of crops in my data set. After the third step, to apply that model on the training set and to calculate the performance metrics. So here we are applying the model on the test set. We train the model, now applying the model on the test set to get the accuracy. To get the accuracy, we are using the performance scoring, performance classification operator. So this is like the detailed data pre-processing. You can see here we do load the CSV, then replace missing values, do some feature engineering, and do the normalization. This normalization is important because the data can have the different values, the range can be differ, so this can lead to the bias and the poor performance in the model. So what we did, we took a normalized data and given range 0 to 1, and this will help the algorithms like KNN, SBM, decision tree, because these algorithm works on the distance based. So if the data is normalized, to calculate the distance between the data points will not create any bias in the model. So this is a model training and validation. I use the k-fold cross validation. The k value is 10. This is by default. You can also go with the split data. Split data, that is like you can divide the data into training and testing set by the ratio of 8 by 2, 80%, 20%, or 70/30 as per your wish. In the decision model, like I use the decision tree operator to create a model for that, and you can see that the parameters like maximum depth of the tree and the minimal leaf size, and this parameter for the k validation is like what kind of sampling you are using. I use a stratified, and the number of folds like I have used, which is 10, the number of k value. So this is the results I got from my custom model, custom process. You can see the performance matrices like classification error, accuracy, precision, kappa, and recall. Accuracy is 98.95%. Okay, so there is also, as I have already told, the AI studio give us a feature like SHAP values. We do calculate these values, which help us to explain the impact of each feature on the model's prediction. And I use this in my data set, and the key insight from the data set and SHAP analysis I got, the rainfall and the humidity are the most influential factors in determining the crop type, ensuring the adequate moisture in the level and the critical for the crop selection. Okay, the second thing like the soil nutrients, nitrogen, phosphorus, NPK ratio, you can see here, they also play a significant role in highlighting the importance of balanced fertilization. Okay, in conclusion, the optimizing irrigation in the nutrient management can significantly enhance the crop yield and the selection accuracy. Okay, second method is to create a auto model. That is very nice feature given by AI Studio. You can easily create a and deploy model. Simply, these are the things you have to do. You have to load the data set, the data set you want to predict, you want to use in the model. You can select the task, what task you want the model to perform, whether it is to predict something, whether it is to classify something, or to do some clustering by using some different kind of unsupervised learning algorithms and supervised learning algorithm. Okay, now the prepare data set. To prepare the target, this is we have to decide what is the column attribute which we want to do, and we want to make it as a target variable. Now select the input. So these are the things that we do in the data pre-processing part. And now selecting the input, like what inputs, what features we want to keep in the model. Here is the model type, what different models you will choose to compare the different algorithms. So I have used four algorithms: logistic regression, decision tree, random forest, and support vector machine. So after doing the model comparison and the result, I got 86.5 is the highest accuracy given by the logistic regression, which is really very nice and very effective. This is the it's not we can say it's not overfitting. Also, the accuracy is very nice, and decision tree is also good, 80.1 80.3%. Random forest 81.6%, again better than decision tree. And support vector machine, it is very low, 58.3%. Now you can see this is the overview of dashboard sort of thing. We can see you can see like this the accuracy bar graph, and you can see the logistic regression, the accuracy 86%, entry random forest, and this runtime of each algorithm. So you can see this comparison given by the auto model overview. And here are the models, different models will be there. You can simulate the model, you can perform some analysis, you can predict, and you can weight the features according to you. Now if I talk about the next step for the greener future is to scale the solution. The first phase will be like to include some IoT soil sensors to get the real-time monitoring data. And second phase will be like to do some collaboration with the government bodies and do some agriculture partnership with them, so that we can scale the solution and we can improve the accuracy, and we can also build a better model to predict the crop type, which can definitely help the farmers to grow and build nice things. Now third phase will be like to like carbon credit system, sustainable farming, and incentives. Okay, so before jumping like before doing this project, I did this machine learning professional certification given by Altair Engineering Inc., which is like this certification program is very nice. The content given is very nice. This helped me a lot in doing this project. In this, you will learn from basic to advanced algorithms with proper demo of AI Studio, how we can apply the algorithm, how we how we do ETL process, how we perform different validation techniques and different algorithms using, do some EDA part. Everything is explained very nicely in this course. So this helped me a lot in doing this project. Okay. Now I will go through the AI Studio and I will show you some things what I did. Okay, so this is my Rapid Miner AI Studio, and this is the space blank, the space where we create a custom process. You can see I use read operator. Here you can select the operators. Different operators will be there. And there's the categories here. For data access, you are given different operators. Like if I talk about this, so reading the data. So here you will get different kind of data you can import. It can be in of URL form, Excel form, CSV form. So I have data of CSV, so I use read CSV here to get the data. You simply you have to drag and drop here and double click, and you can extract the data. Okay. Okay, then I use the replace missing values by using the main. If I click on here, you can change the different parameters in it. So I use a subset because I wanted to impute the all the numerical columns. So I use a subset so that I can select the all numerical columns and do some imputation. So these are the numerical columns in my data set, and this is the crop type, which is not numerical. It's we can say it's a string type of data is there. So different categories are there. So I applied here, and this is like default. The mean average is the default. You can choose minimum, maximum, zero, or other values. Okay. Now in generating this, now I have generated NPK ratio. This is like using this operator generate attribute. You can simply write it here and get the operator. Now this is the operator that I have used to generate a new column in my data set. Okay, now here I have it. See, this is the column name that I have given and the function expression. What I want, what kind of data I want. So this is the function expression by like n plus p by k. Okay, then I normalize the data in the proper range to keep the data in the range. So I use min max 0 and plus 1. I selected this subset, and you can also apply it on all, but here we won't be able to apply all because we have some different kind of data types for the columns are there, so we can't use directly here. So we have to select a subset and then select columns. So I have taken these are the columns to do normalization. We do normalization for only in the numerical columns. Okay, now we will select the columns which will be stored for the validation and the, training the model. Okay, so I have stored the data. So I got the data. Now I stored it. This is the repository where I have stored. You can see here, like for SHAP values, the repository. From here I stored the data. And now I did the cross validation. If you double click on here, you can see the cross validation. Here I applied decision tree model, and then I applied the model on the test set, and then I calculate the performance by using this performance classification operator. Okay, now come to the process. Okay, now applied the model here, and you can see this is explain predictions that create give SHAP values safely additive explanation. So these values very helpful for uh, to for feature importance and to know the model's inner working. Okay, now I have saved the data and by using the write CSV operator, and then I use the performance operator to do the scoring for the model. And here I have the criterion chosen is accuracy, and these are the things you can include in your final whatever you want to get. Okay, if I want to include the absolute error, I can include the absolute error also. So I've included accuracy, classification error, kappa, weighted mean recall, precision, and the absolute error. Now after doing this, the process is finalized, and now I will run the process. See, it's taking time. It's creating the values for the SHAP values. Okay, now my model is ready, and this is the confidence interval for the for each crop prediction. It's like basic. We can see the confusion matrix sort of thing. Okay, now this is the crop type, and this is the prediction crop type. Okay, now the confidence for the one rise. To predict the rise, the confidence is 1, which is like it's correctly predicting. Okay, if I see here this rise and the predicted is June. This is like the confidence for rise is like 0.16. It's incorrectly predicted. Okay. Now you can see here these are the different attributes, and this is see this is created by prediction explanation operator, which is like SHAP, which will be used to calculate the SHAP values. You can see it's created support prediction and contradict prediction variables, like sorry, but not variables, the attributes automatically. And these are the columns, the NPK ratio, everything, all the values are normalized. You can see here. Okay, now to see the performance vector. This is the matrix, performance matrix. You can see the accuracy is 98.96. Okay, we want to visualize things in a plot way. You can visualize in 3D form, and if you want to see in this table view, you can see this. and the classification error is 1.05, kappa is 0.989, and weighted mean recall you can see here, and its weighted mean precision, and the absolute error is from like plus minus to like 0.018 and plus minus 0.09 that we can see. And okay, now after doing this is my custom process. The method one is to do custom process. Second method is like I have already saved the model, auto model for the crop recommendation, and here my the saved result are like here for my auto model. Okay, so you can see in the first thing is to load the data, then select the task, and then prepare the target variable, and then select the inputs, what variables, like what features we are going to put into the model, and select different kind of models. Okay, and then finally we got the result. It will do some training, it will take some time to give the results. Okay, now here you can see I have used four algorithms: logistic regression, decision tree, random forest, and the support vector machine. Okay, now see the classification error and the accuracy. Here the classification error is like 13.5%, 19.7%, 18.4, and classification error is very high, and the leading to accuracy low accuracy. Okay, now if I come to this accuracy, see, the accuracy of the logistic regression is 86.5% with a given plus minus 2.2% of standard deviation. And here you can visualize using the bar graph is the given accuracy is there for the different models. I have taken only four, but there will be different many other models also will be there. Okay. Now if I want to see the model, okay. So these are the given binary models. Okay, now the attributes are like NPK, temperature, pH value, rainfall, and the intercept. So this is the intercept is given, and the p value is there. As you know, p value, z value, standard error, standard coefficient is there. Okay, and okay. So here is like weights. What weights like? What is the weight given to the particular column? So if I talk about my data set here, the potassium is having higher weight than supported by this like after okay, potassium is highest, then the rainfall, then the pH value, and the later on other things. This is like importance, we can say importance, what is like how much importance each model like each attribute is having. So this case there. Okay, this is simulator the sort of things. You can change the values according to you. You change something like this, you can see, and there is a change in the importance factors for the jute. Okay, and okay, great. Now see, you can here you can change the things, and you can visualize automatically change in the values. Okay, that you can do. And here is the like performance. So accuracy is 86.5%, the classification error is 13.5%. This is like confusion matrix is given. Okay, so this is the prediction that is there, you can visualize here, and the prediction model that is okay, for the logistic regression. Now if you want to see for the decision tree, you can view the model. A tree will be drawn here. You can see this is the tree, and the depth of the tree that we have taken is for was at 10. So this is the tree, our model, and the weights are as usual that not that we have already seen. The weight, potassium is all having highest weight in the here logistic regression. Also the weight of the potassium was highest, followed by the rainfall. But for the region tree, the weight for potassium is highest, and followed by humidity. Okay, for the random forest model, you can view this. This is the random forest model. Okay, and this is weight. Again, the rainfall is having the highest weight in the random forest model, and followed by the humidity. That's why we see in the SHP values like humidity and the rainfall are most influential factors for the prediction of the crop. Okay, so this was the AI studio that we can do and design the process, our custom process to make some predictions and create a model in the workflow for betterment of the crop prediction, which can help the farmers to grow the crop accordingly by seeing the data and the values. Okay, now to calculate the SHP values, I use Python. So I use this was my prediction CSV that we created. I saved it in my local repository in local file. Okay, now these are the you can see support prediction and contradict prediction created by explain prediction by operator that I used in the AI studio. You can see here this explain prediction operator. Okay, this created these columns, the contradict prediction and the confident support prediction. Okay, now for the SHP interpretation, yeah, okay, for the SHP values, I use this model. I did some statistical analysis. I did some EDA part, and for the imputation, there were some missing values were there. So I used KNN imputer because and the number of missing values were higher. That's why I use this. This will impute the nearest k nearest neighbor sort of thing. It will so I have taken the number of neighbors 5. Accordingly, it will impute that particular missing value by taking the uh, values from the top near 5 in data points. Okay, you can see this is like histogram for the each attribute. I created this box plot to visualize whether there are any outlier present in data set or not. This is like a matrix correlation heat map. You can see the potassium and this phosphorus are high, like more correlated by the value of 0.74. This is positively correlated. And now to get the values for SHP values, so you can see here the features are there. This is like mean SHP values, and the highest the influence factor is rainfall, humidity in the phosphorus. These are the three highest influential features which are influencing the crop prediction in the model. Okay, you can see here the values of rainfall is 0.9 for importance, humidity is 0.87, and the phosphorus 0.68. Rather, all are like it's low, but they have the significant impact of the prediction. Okay, these are some plots you can see dependence plot for the different features SHB values. Okay, this was the project that I have done, and it was a great experience for me, and I learned lot many things. Uh, Basically, how to use the AI Studio. It helped me a lot, and thank you.